In this tutorial, we're going to look at CyberChef. CyberChef is an open source web app with around 300 operations for encryption, encoding, compression, and data analysis. I'm going to guide you through its interface, show you how to perform basic and complex operations, and give you some tips on making the most out of this tool. First, let's navigate to the CyberChef website. Here is the main interface. On the left, your operations or ingredients. In the middle, there's the recipe area where you drag and drop operations. And on the right, you have your input area where you'll paste the data you want to work with, and you can see the output window here, which displays the results from your recipe. A few tips to make your life easier. Use the magic operation if you'd like the app to attempt automatic decoding of unknown formats. It will appear down here whenever CyberChef thinks it can help you. I'm not going to use it for this demonstration, but you'll probably find a good use for it. You can hover over an operation here in the selection panel, and a description of the operation will appear, as well as a link to more information. And we land on the Wikipedia page for base 64. And finally, AutoBake will automatically run the recipe for you. Let's look at some basic operations. Favorites has some defaults preloaded, however, you can edit these if you like. Data format for your hexadecimals, binaries, etc. Encryption and encoding, which is where you'll find some really useful operations for a CTF. ROT13, Visionaire, Railfence, Substitution, Enigma. There are a lot of categories and operations to explore, so take a little bit of time to have a really good look around. In your recipe window, you can save, load, and clear. You can load files or folders in your input window. And moving down to the output window, you can replace your input with your output, and you can save your output as well. Let's look at some of these tools and decrypt a cipher. First, we'll paste this ciphertext into our input field. Looking at the frequency of the letter G and Y, they don't really come up this often in English, or the letter V for that matter. So I'm going to guess that this is a substitution cipher where each letter has been replaced by another letter from the alphabet a bit further along. With that in mind, we'll start with a Caesar cipher or ROT13. So let's search for our operation. We'll drag ROT13 decode into our recipe area. And you can change the rotation from 13 letters to something else if you don't get it right the first time. Now we'll hit bake, which will execute our request, and as you can see, CyberChef quickly converts it. And here's our message. This quote from Julius Caesar: "Experience is the teacher of all things." Now let's encrypt a message using a Railfence cipher. This is a transposition cipher, meaning the characters in the message are scrambled as opposed to substituted. A Railfence cipher works like this. You can see the zigzag pattern. Some say it may resemble a fence. We have our rows that determine the secret key we're going to use to decrypt our message, which we'll share with the recipient. It's like symmetrical encryption. You can see the original message flows diagonally downwards and upwards along the columns, and our encoded message is there in the horizontal rows. We've selected our Railfence cipher encode operation and we've dropped it into our recipe. Let's input our message and we'll choose the number of rows for our key. We'll use 6 rows. The best way out is always through. So we've provided our message, we've made our key, and CyberChef has done the encoding for us. Now, on a side note, if you're trying to identify what kind of cipher you're dealing with here, you might spot a transposition cipher by looking at the frequency of vowels and other common letters, since they are only being rearranged and not completely replaced. To decrypt a message you suspect could be a Railfence cipher, we use the decode rel-fence cipher operation, and we can play around with the numbers until we find the right key. We're familiar with the drag and drop, so now we're going to add some more steps. CyberChef allows combining operations to create complex recipes. We'll use two examples here. We'll encode a message, and we'll decode a message using a handy operation called the fork function. For our first example, we'll encode our message using a substitution cipher. Then we'll convert that message to hexadecimal, and maybe we can come up with a clever hint and we'll send it over to our friends to try and solve. If you reveal your secrets to the wind, you should not blame the wind for revealing them to the trees. We have our message for our friends, so we'll start encoding by dragging the rot13 operation into the recipe area, which of course shifts each letter by 13 places along the alphabet. After applying our substitution cipher, we'll drag this to hex operation into our recipe to convert each character. Hexadecimal, if you don't know, is a number system consisting of numbers 0 through 9 and the characters A through F. Looking at the characters is a great way to quickly identify hex. If you come across a large alphanumeric number, you won't see any letters above F, so they'll only go A to F. And here we have our encoded message. We'll send that off and we'll let our friends figure that one out amongst themselves. Now let's look at the fork tool, which is helpful in situations where you need CyberChef to treat the input as multiple strings or lines rather than one long string. We have our secret message here, which is a bit of a hot mess. We can identify what language we're dealing with again, just to help us figure out how we'll decode this in CyberChef. Here we have equal signs at the end of these two strings. Base 64 is a 64-character alphabet and often uses the equal sign at the end of a string to pad it out to the correct size, so that can often be a giveaway. However, not always, as you can see in this middle string. But the equal signs are here on these other two strings, so we're going to say this is base 64. Now we drag our fork operation into our recipe. We wanted to identify where a new line occurs in our message. So we're going to tell it to start a new line by placing \n in the split delimiter field. Next, we'll drag our decode base 64 operator and we'll click bake. And here is our secret message. Your scientists were so preoccupied with whether or not they could, they didn't stop to think they should. If I disable the fork operation, you can see how it treats the output as one string. So if you have a large amount of data that you're dealing with, this function can pay off. And there we go. We've chained operations to solve multifaceted problems like those you may come across in CTFs. Another good tip before I go, you can save your recipes for later by clicking here and giving it a name. You can also find a lot of recipes and tutorials on GitHub. Thank you for joining in on this walkthrough of CyberChef. We've navigated the interface, shared some handy tips, and looked at some of the practical applications of CyberChef, from basic operations to creating complex recipes, which hopefully will help you solve some challenges of your own.